Hi friends, in this video we are going to learn about deviation, standard deviation and variance for measurements. Okay, first thing, deviation. Deviation means it is how much a value is deviated from the mean. Di is given by xi minus x bar. Okay, that means we calculate the mean first, then suppose consider the previous example 54.1, 50.2, 54.3. There are four values like this. How much the second reading deviated from the mean? Calculate the mean of these four values. We get a mean from these values. Now subtract subtract the mean from 54.2. We get the deviation. Okay. Next is average deviation. Average means already we have seen mean, it is also average. So average deviation is average deviation given by d bar. It is summation of all the deviations of the ith readings. That means summation of d1, d2, d3, d4. Summation of all the deviations by total readings. Okay. That means d1 plus d2 plus d3 plus d4 by 4 gives the average deviation. Next is standard deviation. Standard deviation is given by sigma is equal to summation of all the deviation square by n. It is given by the summation of all the deviation square by n. So basically for n less than 20 readings or 20 items, we take sigma to be di square by n minus 1 for n less than 20. If more than 20, we will take this one, and greater than 20. Okay. Next comes is variance. Now, as we already know, we got deviation. What is the variance? Is sigma square. Sigma square is the variance. So it is given by di square by n minus 1 for n less than 20. Sigma di square by n for n greater than 20. This is all about deviation, average deviation, standard deviation and variance. Now you practice one example given by readings. Suppose a car is owned by seven owners, and they all each went for a tour. Okay. When they went for a tour, the petrol consumption was given by the first person used 54.1 liter, 54.2 liter, third person is 54.3, 54.5, 54.6, 54.7. These are the liters of petrol consumption by each owner. Now calculate the mean, calculate the deviation, calculate the average deviation, calculate the standard deviation, and calculate the variance. So already we know the formulas. This is xi. Now if I calculate the mean, I get x bar. So for each and every value I get a deviation. Okay. Then average deviation. I got each and every deviation. Add up all and divide by the 7. We get average deviation. Next thing is we already got each deviation from this. So you square it and add them all and divide it by the total number of readings and give a square root. Then you get standard deviation. Remove the square root, you get the variance. This is how we calculate deviation and standard deviation variance of a given readings. Okay. I'm using 54 because 54 is more popular in our class. That's why it became my favorite number. Now, the next concept for numerical is, actually he has a 100% attendance in a class, DC voltmeter. DC voltmeter using PMMC. PMMC. Okay, where PMMC is given by permanent moving magnet, permanent magnet moving coil. PMMC is permanent magnet moving coil. Okay, now you already know that, okay, this is a permanent moving coil magnet. It has an internal resistance of Rm. It is called a meter resistance. Okay, and Im is the full scale deflection current. Whenever I add a multiply resistance in series with this, here I need to calculate. So I am using as a voltmeter, so I need to calculate the voltage. So I'll calculate my voltage here. This is Rs. It is in series with the given meter, PMMC meter. Why I need to add in series for voltmeter? Because to minimize the large currents, I need to add the resistance in series. Okay, so that some voltage drop will be there here, and I get a minimum voltage here. Right? Now they'll give this. They'll ask us to find out the multiply resistance. This is called the multiply resistance actually. Rs is called multiply resistance. Rm is the internal resistance of the PMMC. Okay. Now they'll ask us to find out the multiply resistance to measure this this voltage. Okay, if given Im and Rm, right? Now by seeing this, as it all are in series, we know that if Im is the current flowing in this PMMC meter, the same will be flowing here also. They are in series, right? Now write a KVL. V equal to Im Rs plus Im Rm, right? V equal to Im into Rs plus Rm. Okay, Rm is the internal resistance, Rs is this. Now if we want to measure Rs only, then take these terms here, equal to Im Rs. Now divide it by Im, I get V by Im minus Rm. Okay, these already we know. This is they'll give this one, they'll give this one. We need to find Rs. Okay, that's it. And here one more thing, one more concept is multiplier. As we are calling it a multiplier resistance, that multiplication factor is given by capital V by V. This is small v. Small v is the potential difference across IMRM. I mean, potential difference across PMMC, and this is the actual voltage to be measured. This gives the multiplication factor. This is how we already got V as Im into Rs plus Rm. Okay, by this is M. It is given by small m. Okay, V by V. Now what is small v? Im into Rm. Just we cancel out this one. M equal to 1 plus Rs by Rm will be my multiplying factor. Now this is also can be written as M into Rm minus 1 is equal to Rs. In this way also we can find the Rs. If they give a multiplying factor and they give the resistance of the meter,